The spacecraft was built to watch the sun. Every day, it faced the same direction. Solar panels drank in light. Instruments studied eruptions and storms boiling across the solar surface. From a point roughly 1 million miles from Earth, the Solar and Heliospheric Observatory, SOHO, did its work quietly. Then, during what should have been routine maintenance, something began to slip. At first, nothing about the spacecraft looked dramatic. There was no collision, no explosion, no burst of debris crossing space. Control commands were being sent. Systems were being adjusted. The observatory was still where it was supposed to be. And yet the one thing SOHO could not afford to lose was beginning to disappear. Its ability to keep facing the sun. A spacecraft like SOHO survives through orientation. The sun is not just what it studies. The sun is its source of power, warmth, and stability. Point the wrong way for long enough, and sunlight becomes useless. Somewhere inside the sequence of maintenance activities, control of the spacecraft's attitude began degrading. The observatory drifted. Then drift became loss of control. From Earth, engineers watched telemetry streams that normally described every important condition aboard the spacecraft. Voltages, temperatures, position. The information became harder to trust. Commands produced unexpected results. The spacecraft no longer seemed to know exactly where it was pointing. A simple question emerged from the growing confusion. What exactly had broken? The most obvious answer was also the most frightening. A catastrophic onboard failure. That explanation seemed to fit the evidence. Attitude control was gone. Communication was deteriorating. The spacecraft was becoming increasingly difficult to manage. Then, the voice disappeared entirely. Telemetry stopped. Communications ceased. Screens that had once described the condition of the spacecraft froze on old information. The observatory was still somewhere in space, but it could no longer explain what was happening to it. Silence became the dominant fact of the story. Days passed. From Earth, there was no reliable way to know whether SOHO was healthy, damaged, tumbling, frozen, or already beyond recovery. The spacecraft had become something strangely similar to a missing person. No voice, no status report, no visible body. Only absence. The temporary explanation grew stronger. Perhaps the spacecraft had suffered a fatal failure. Perhaps there was nothing left to recover. Yet one uncomfortable detail refused to disappear. Nobody actually knew. The spacecraft had vanished from communication, not from existence. So attention shifted from listening to searching. Large radar facilities began looking for something that could no longer speak for itself. Across enormous distances, powerful signals swept through the darkness. Eventually, something answered. Not with telemetry. Not with a health report.
It all depends on keeping
only with presence.
above the minimum threshold.
Radar observations showed that SOHO was still there. The spacecraft existed. It had not exploded. It had not broken apart. Instead, it appeared to be tumbling. The missing spacecraft had become a found spacecraft. And that changed everything. The audience of engineers waiting for signs of life now faced a new problem. Location was not communication. Knowing where the spacecraft was did not reveal its condition. The ghost had been located, but it still could not explain itself. As more evidence accumulated, a clearer picture emerged. SOHO was rotating through space. Sunlight struck it from constantly changing angles. The spacecraft was surrounded by the very thing it needed to survive, yet unable to use it reliably. Its solar panels could not consistently face the sun. Power generation became uncertain. Temperatures dropped. The crisis changed shape. Finding the spacecraft had not solved the problem. Finding it had revealed a survivor in trouble. Now recovery became physical. Every watt mattered.
Execute the recovery plan.
Every degree of temperature mattered. Deep inside the spacecraft were hydrazine propulsion systems needed for control and recovery. If temperatures fell too far, those systems could freeze. The rescue was no longer about communication alone. It was about warmth. A strange contradiction now governed every decision. SOHO needed power to regain control. But it needed control to reliably generate power.
R52 procedure.
The spacecraft was trapped between two requirements that depended on each other. Engineers responded carefully. Commands were sent in small steps. Signals were monitored for tiny changes. There were no dramatic breakthroughs. No sudden return to normal. Instead, recovery advanced through fragments. A carrier signal. A response that suggested a subsystem was still alive. A piece of telemetry that returned after silence. Each new signal carried the same question. Was this meaningful? Or merely temporary? Weeks earlier, silence had suggested destruction. Now intermittent responses suggested something different. The spacecraft behaved less like a wreck and more like a patient emerging from unconsciousness. The major obstacle was not damage. The major obstacle was information. Nobody aboard could explain what was wrong. Everything had to be inferred from behavior. Gradually, sunlight began working in SOHO's favor again. Periods of improved orientation allowed better power generation. Better power supported additional recovery efforts. Temperatures improved. Systems that had been threatened by cold moved farther from danger. The observatory was not healed, but it was surviving. The image that had defined the crisis, a dark spacecraft tumbling near the sun, began to change. Solar panels started catching light more effectively. Control slowly improved. The spacecraft learned, in a mechanical sense, how to stand again. Attitude recovery progressed. Stability returned. The observatory that had once vanished into silence became increasingly responsive. Recovery operations expanded into recommissioning. Subsystems were checked. Capabilities were restored. The spacecraft returned step by step toward the work it had performed before the crisis began. Then came the moment that transformed survival into resurrection. Scientific data returned. The spacecraft was no longer merely alive. It was useful again. The silent observatory resumed observing the sun. The story could have ended there. A malfunction, a rescue, a successful return. But the final investigation changed the meaning of everything that had happened. The evidence no longer fit the original explanation. If a catastrophic onboard failure had caused the crisis, the spacecraft should have shown signs of catastrophic damage. Instead, it had recovered. The more engineers reconstructed the sequence of events, the less the spacecraft itself resembled the primary culprit. The earlier belief collapsed. The observatory had not been destroyed by some hidden internal anomaly. The major loss of attitude had originated in groundside operational errors that triggered a cascading survival crisis. The spacecraft had spent months carrying the blame for a failure that was not fundamentally its own. Which brings the story back to its opening contradiction. A sun-watching spacecraft nearly froze because it could not face the sun. What first appeared to be a disappearance became something else entirely. A rescue. A machine vanished, was found, was heard, was warmed, was stabilized, and returned to work. In the end, the most dangerous thing lost was not power, fuel, or hardware. It was information. And when the first scientific signals finally flowed again from the recovered observatory, the sunlight surrounding SOHO no longer looked like an indifferent background. It looked like the resource that had helped bring a silent spacecraft back to life.